So I want to start this talk off with a little story that I hadn't originally included in this presentation, but after watching the last 3 days, everything that's happened here and the various talks presented by various people, I find the story to be nicely analogous to some of the things I see here. So back in the day, when the x86 computers first started going 64-bit, there was a period of time where internally inside Red Hat, there was a bit of a war taking place over what we should be recommending to customers. And I was at the center, or one of the center people in that war. And it's because somebody had made the recommendation that if you were going to 64-bit for any given workload, you needed to have at least twice as much RAM. And me being a low-level system guy working with the kernel, working with C programming language and everything else with strong data types, said, no. You don't double your RAM requirements for this. And the person I was arguing against was somebody using Python. And they sat down and wrote a program and ran it on a 32-bit copy of the OS and checked all of its memory usage. Then they did the exact same thing with Python under 64-bit. And sure enough, it exactly doubled. And so we went through a lot of work to figure out exactly where this was happening and understand each other's point of views. And in the end, I came away with a deeply ingrained bias and loathing of Python, the interpreter. I'm fine with the language. Don't ever want to see that interpreter run. Because it really does double everything. And it doesn't matter what it is, from 32-bit to 64-bit, it stores everything as 64-bit. So with that in mind, I am perfectly happy telling you that I enjoy programming in C. To me, C is a high-level language. I also enjoy programming in Assembler. Assembler is a very powerful, very efficient language. And so that should give you the ability to understand the implications when I say I like programming in verbs. And it really is a low-level network programming language. It's what I would call the assembly language of high-speed networking. So, as an interesting trend then, I see this. The OpenFabrics Working Group, Interfaces Working Group, and libfabric. And the reason I'm interested in this, and the reason I see this as an interesting trend, is because this, to me, feels like the C version of high-speed network programming. So, as I watched the different technology presentations over the last 2 days, especially when I combine that with some memory I have of the past, you have your standard IB verbs. Then we added XRC. Then we added Core Direct. And now we're talking about doing new verbs extensions specifically related to optimized send and receive routines where you can get different function pointers that are tailored specifically to just what it is you're trying to send or receive. And to me, when I see all of this and I hear this, the image that pops into my mind is an x86 processor and then the SSE instruction set, SSE2, AVC. It's the same basic type of progression. And each progression, you get sometimes incremental, sometimes tremendous performance boosts out of these new things that you've added on and tacked on to the side. libfabric is different because it doesn't try to do all that. Now, under the skin and in future versions of libfabric, it very well will try to take advantage of verbs extensions, but it's always going to be higher level. It's always going to be doing things like, if you're programming in assembly, you need to know whether you're programming Intel or ARM or Spark. But if you're in C, you don't. If you're using libfabric, you don't really need to know if you're iWarp, InfiniBand, or Rocky. It just works. And so, to me, when I look out across this room, and I've been to a lot of these conferences, the developer workshops, and I see a lot of the same faces year after year after year. And it seems to me that we've got a fairly good saturation with IB verbs. And libfabric, and quite possibly anything they might put on top of libfabric, is an opportunity to expand the number of people that would normally be in this room and that would be interested in the things going on inside of this group. That we have the opportunity to go beyond all of us assembly language programmers and into some of the higher level places. I don't know that I would ever look for them to do a Python version of programming language for InfiniBand, or ever use it or ship it. No. But I do see this one coming forward. And since I see a lot of saturation of the groups that are really interested in verbs already, if someone asks me in the future what to program to in RDMA, I'm likely to tell them libfabric going forward. And that's because I think the people that want to use libIB verbs are already here. And the people that want to use something a little bit more easy to use but still performant would benefit from libfabric. Of course, I still see libIB verbs maintaining the same role it does today, and I expect it to improve as time goes forward. So the other things that I see is I see a lot of work coming out of Mellanox on the ICER, both target and client. I see a lot of work from BART on SRP, and I see a lot of work from Oracle on NFSO RDMA. And I know that these technologies have not necessarily been pushed in the past, instead deferring to things such as Lustre. When you start having large clusters, the things that the labs use, these kinds of technologies don't necessarily make them all that interested. They need the higher end technology such as Lustre. But moving forward, I would like to see, or actually I'm going to be working to try and move these technologies forward, make them more reliable, more stable, more hardened, and for the importance of the people who might use it, easier to consume. And that's always been one of the problems with new technology, is the degree of difficulty to consume it. And that's one of the things that I view as my role at Red Hat. I'm sure John at SUSE agrees. Our job is to help make it easy for anybody out there to consume the technology that we ship. And so I say that to let you know that one of the things we're going to be doing is targeting this mid-range level of file and block storage and making that easy to consume. We have other products, at least inside Red Hat, we have other products that target the high-end stuff. You guys know about that, Gluster and Ceph and that kind of stuff. But we're going to be making a concerted effort, and as you can see by the list of hardware, this is the matrix that we're going to be supporting this on and testing this on and working on it on. And the really only one of note down there is I do consider MTHCA dead, and it's not going to get any further work from us. Once it breaks and quits working, we're just going to turn it off. And I say that because I know inside Red Hat we've had people that sent in out emails and said, hey, if you want a really fast home network, just go to eBay. The old MTHCA hardware and 10 gig InfiniBand switches are dirt cheap. So yeah, you can do that, but if it breaks, that's not going to last very long. So one of the other areas that we consider to be a hot trending area is virtualization. We've already enabled virtualization for live migration, but not live migration of hosts using RDMA devices. This is just normal devices or normal hosts doing TCP communications that happen to be on hardware with RDMA backend connections. That's not available in our base level product. It's available in the add-on, the Red Hat Enterprise Virtualization. And it only exists in QEMU 2.0 and above upstream. So you have to get the right package in order for that to be enabled. And then Mellanox has been working a lot to enable SRIOV in their hardware, and we've been working with them to get that support in our operating system. And there's been a lot of actual close efforts on that. And so we've got it running in our labs. We've shipped the basic level kernel support for the hardware. As was mentioned in Laurent's talk, there are still problems with configuration. There is no live migration. And the ability to set both the max and the goods on the devices has been problematic. I have some scripts in place that I use to work around it, and I ship those so you could actually take a look at it, but it is strictly technology preview.
Will that support live migration?
No, it does not support live migration. However, if you could structure your host to essentially act like hot plug, if you can tell your guest, tell the guest application, you shut down your operations or whatever, then migrate, then bring it back up, that would work.
Yeah, we figured that out.
Live migration would be something great to have, but without either support for it in the driver, which would be Mellanox, as far as that would be their responsibility. Without support in the driver, it's going to be very difficult to make that work. The only other way to do it is to possibly look at something like libfabric, where libfabric could actually implement the concept of a hot plug device. libIBverbs doesn't support it, but I think that's something we could add to libfabric. But I've been very pleased with the results of the SRIOV. As I said, it's only MLX4 at the moment, but it has been extremely performant. I know when I first started coming to these workshops long enough ago, I probably wasn't nearly as white as I am today. They had originally talked about the benefits of SRIOV, but it's taken a long, long time for it to actually materialize. So I ran some simple tests, and these are by no means exhaustive, but I took a 4-socket system laid out such that 2 sockets were next to the PCI buses and 2 sockets were pure compute nodes with no access to PCI whatsoever. And I pinned the guests on the compute nodes and then left the host free to use any of the CPU sockets that are connected to the PCI bus. These are Mellanox ConnectX-3 cards. They are not ConnectX-3 Pro, so that might actually affect a little bit the encapsulation of some of the results I got. But I did find the results interesting. Going from the host to the guest, as you can imagine, TCP bandwidth was limited more or less by the CPU's ability to do memcopy and checksum. And so it used an extremely high CPU utilization doing all of that checksumming, and it came out at about 2.8 gigabytes per second. UDP looks nice, where it says 9.8 gigabytes per second, but the one thing that I need to let you know is that the UDP numbers there in this circumstance are not balanced. The sending side totally trounced the receiving side. It just saturated the available CPU power. But all of the reliable connected bandwidth, with the exception of one spot, was very pleasing. And as you can see, the 5.4 gigabytes per second number pops up over and over and over again. And as it turns out, I did the math, although I didn't actually, I did the math for an X8 PCI Express Gen 3 device. This is actually pretty close to theoretical maximum of how fast it can move the data. There's a little bit of room available. I think that's about 85% of theoretical maximum, so maybe it could go a little bit faster if the PCI driver on the card was tuned a little bit more, maybe had a bigger queue depth or something like that. But when you're talking about host to guest and guest to guest, the PCI bus is bidirectional, but because of the fact you're transferring in and out, you're using both directions for a single direction of copy, which is why you do not get any improvement on your bidirectional bandwidth. And so the net result is, when I looked at all of this, was if you wanted to, you could plug a PCI Express InfiniBand card into a big box with lots of virtual guests on it, and you got yourself a very expensive but very fast memcopy device for memcopy offload. And so it brings down the CPU utilization greatly, while still transferring data considerably faster up to the maximum speed of the PCI bus. New generations of cards are going to be X16 instead of X8, so you can expect that transfer speed probably to go ahead and fully double. But what I really liked also was the remote host to the guest, because when you have a lot of hosts on a single guest, or a lot of guests on a single host, your bandwidth in and out of that host can be a considerable bottleneck. And RDMA technologies in general. I actually ran the tests over Rocky and InfiniBand. But as far as the remote host to guest TCP and UDP, that was over Rocky so that it got the native device and not IPOIB. However, this is why I also said I noted that I did not have the ConnectX 3 Pro, so it might have had an effect on that. But still, getting the data in and out of the machine and to the guests is considerably faster and far more CPU efficient than any other method. And so with that in mind, I'm happy to report that, for instance, we see other technologies besides just the large-scale clusters. And so one of the hot items that have been coming out in the last few years has been OpenStack. And I can tell you that OpenStack already has support for RDMA, especially like the OpenStack Cinder backend storage and stuff like that. So these are all things that we see as being exciting going forward, and as a great opportunity to, again, expand the size of this room with people that are doing other things besides what the guys at the labs and big MPI clusters are doing. And so that's kind of the stuff that we see and that I find very interesting. And that pretty much covers it.